So, Jai Hind all of you once again. I am Manish Kumar, Assistant Professor in Department of Computer Science and Engineering at Kumar Garg Engineering College. So, today my second complex topic is on stack and queue. So, today I am brief you about the different operations that we perform on stack, that we perform on queue, and its implementation in C language. Okay. So, previously we have discussed about, we have defined key what is a data structure. What is a data structure? So, what is data structure? Data structure is defined as a mathematical and logical representation of the information, right? And we have divided the data structure into two types. Okay, that is primitive and non-primitive, right? Primitive is further divided into linear and non-linear data structure. In linear, in my first lecture I have discussed about arrays. Secondly, I am going to discuss about these two linear data structure, that is stack and queue, in my today's lecture. Okay, so let me start with the introduction of the stack. So, in today's lecture I will discuss about stack and queue, as I have said. So, what is stack? Stack and queues, these both data structure are the data structures where we perform the operation on either end, any of the end. Okay. So, stack is defined as a linear data structure that is defined as a collection of items of the same type, because we have studied the same type of elements which can be accessed sequentially in sequence one by one. That fashion is called as in linear data structure. Okay. Stack is given a special name that is called as LIFO, last in first out, because the arrangement of elements are in such a fashion that the element which is inserted at last will be the first element that we will delete, that is popped out. Okay. So, insertion and deletion of elements will happen at one end in case of stack. Okay. So, this stack is also called as an abstract data type, because what is ADT? Abstract means abstract means we are just going to hide the implementation, we are just concerned with the operation that we have to perform. Okay. So, ADT, this stack is an example of ADT, abstract data type. So, for example, if I explain you with an example, in a real world scenario, we have seen the deck of cards or a pile of plates. We have attended several functions, marriage function, birthday parties, where we used, when a dinner is started, we just used to pick the plate. So, from where we are going to pick the plate? From the stack. So, this is an example of a stack, right? This is an example of a stack, a deck of card. So, what we are going to do when we take off a card, the card is taken out from this one end, the plate is taken out from this one end. When we put the plate, this is same end will be considered here. Okay. So, this is an example of stack. So, we can represent stack either vertically or we can represent it horizontally. There are two representation that we represent it. So, this is a stack. Okay. So, just keep in mind, when insertion and deletion takes from one end, then that type of data structure is called as stack data structure. Okay. So, this is in diagrammatical representation. So, you can see here. So, in stack, the two important operations that we will consider, push and number two is pop. So, push means this insertion operation will take place here. So, this insertion operation is called as a push operation, and the deletion operation that we will consider here is called as pop operation. So, as you can see, the number of data elements are here. Okay. So, when elements are inserted, there is only one end. This is a push operation, and the element when we delete, this is only the same end is there. Okay. So, what happening? This is the last element. So, the element which we have inserted last, we are going to delete it. So why we call it last in first out, that we have defined it a short form that is called as LIFO, last in first out. Okay. So, what are the different operations that we perform in a stack? That is push operation. Push means we are going to insert the element. Pop operation, we are going to delete the element, going to remove it. Push is adding, deletion is pop operation. Another, there are three more operations that we will check here is empty, is full, and peak operation. Is empty. Now, when we talk about different operations, we will check either the stack is empty or not. Okay. So, to check whether the stack is empty, we will call a function called as is empty, which will check whether the stack is empty or not. Then there is another function that is called as is full. We will check ki stack is already full or not. Then there is a peek operation that will give me the position of the top data element without removing it. Peek operation did not remove the element, it just point me at the top of the element. Now the question arises that what happens in a stack? Actually, what happens when we will have a special variable that is called as top of stack, top top. This is the name of a special variable. In some text, top is there or tos, top of stack. This is the name of a variable which will keep the track of the element where we are exist in this stack, this top and top of stack. Okay, we can give the name top or tos. So initially what happened, the stack is empty. So what we are going to do, we want to initialize this variable. So if the stack is empty, then top is pointing here, there is no element there. Okay, when we will insert first element, we will increment the value of top. Second element is inserted, top is equal to top plus 1. Third element is inserted, top is equal to top plus 1. So whenever the element is inserted, the top variable is updated. When we delete the element, then what happened? Top is equal to top minus 1, top will point here. Again we are going to delete the element, top is equal to top minus 1, point here. Then again we will delete the element. So we will check whether the stack is empty or the stack is full. Stack is full means if the maximum size is reached here, max size is reached here, that is the size of the stack, then it will give the is full condition is there. And if the stack is empty, we will check whether the stack is empty or not. It is checked with the help of is empty. That we can also set overflow and underflow condition. Overflow means if for example if we kept a bucket, then if water is overflowing, then water will come out from that bucket. It means we can't put more water in that bucket, hai na? If the bucket is already empty and we take a mug and we are just taking out the water, that is not possible. It means the bucket is empty. Then we will check it is empty, and if it is full, then we will check it is full. The same operation is here. We will check before inserting if the stack is full, and before deleting we will check is my stack is empty or not. Okay. So how stack works, this is important, we have to check. So initially we will set a pointer. Just I have brief you about that pointer is top, or we can say it peak. Okay. In some text this pointer is named as TOS also, TOS, top of stack. And what is the role of this pointer? This pointer will just keep the track of the topmost item in the stack. Okay. So initially what we will do, we will set that pointer to -1. Okay. -1 means we have just initialized that variable and we are getting ready this variable to take the value. So before starting we will just initialize the stack. And what is the meaning of initializing? Initializing means we are just keeping a value -1 in this variable top. Okay, na? As we add the elements to the stack, the position of that peak element will keep updating. Top is equal to top plus 1, top is equal to top plus 1, like that. Okay. As soon as we pop or delete an item, then again that top is again updated. Top is equal to top -1, top is equal to top -1 means in the case of insertion, this top is updated like this. In case of deletion, that is pop, the top variable will be updated by decrementing the value. Okay. So now how we are going to implement this operation? So as I have said that firstly I am going to initialize the variable top is equal to -1, means we will check stack is empty. If stack is empty, then what we will do, there is no need to delete the element. Okay. And overflow condition is checked with the help of top is equal to max -1. Max -1 is the capacity of the stack to keep the elements. So top is equal to max -1. If it is true, then stack is full. So when we insert the element, then overflow condition will be checked. So while inserting, we will check top is equal to max -1. While deleting, we will check top is equal to -1. Okay. These two basic things that we have to check before implementing. Okay. Always keep in mind this condition is checked when we delete the element. Delete means when we are going to pop the element. Okay, this element, this condition is checked when we are going to insert the element. Okay, so what will happen? Let us say I am going to insert the element. So I have checked. Firstly, I have checked is top is equal to max minus 1. If it is, then it will print overflow and we will exit from the loop. Otherwise, the operation will be performed. How it is performed? For example, I have just initialized a variable top is equal to minus 1. Okay. Now, I am just going to insert the element in a stack. So, I have initialized this variable. So, what happened? Firstly, I will create the position where I want to insert. So, how this position will be created? I will increment the value of this. How it is incremented? Top is equal to top plus 1. So, after doing this, this top will point to this position. So, firstly I will create the position, then I will going to insert the element. So, how I am going to insert the element? The question arises now. So, basically there are two types of implementation that is possible in the help of stack, in the stack. So, in stack, the first implementation is with the help of array, that we called array implementation. That is my static implementation. And the second implementation is with the help of linked list. That implementation is dynamic. So, there are the two ways by which we can implement the stack: array implementation and linked list representation. So, in both the cases, firstly I have to check for overflow condition in case of insertion and underflow condition in case of deletion. Okay. So, I just brief you about the insertion and deletion while using this array implementation. Okay. This is easier to understand. Okay. So, in case of, firstly what we will do, we just declare a variable where I want to insert the element. Okay. I just want to insert 5 elements. So, I will just initialize int a5. So, I have just declared a variable a. Okay, I just want to keep the array. So, how it is possible? So, I know that whenever I will going to use this stack, firstly I have to declare a array, number one. Secondly, I have to declare a variable top, which will give me the current location where I will exist in the stack. So, for this, the easiest way is to define a structure of stack. We will declare a stack structure. Okay. So, we will declare a stack structure. Whenever I am going to declare a variable of a stack, so what happened? Automatically an array is declared, number one, and secondly a top variable is there that will keep the track of this element. Okay. So, what happened? So, firstly what I have to perform? I have to firstly create the location for inserting the element. So, how it is done? By incrementing the top variable, top is equal to top plus 1, number 1. Secondly, then what happened? I will just at that stack, that array. What is the name of the array? In that stack where that top will point, I will just insert an item that I am going to insert. So, in this case, the array name is A. So, I will keep array A, and this is the variable top. So, I will insert that particular value here. Okay. So, this is simple operation. Okay. And what happens in the case of deletion? In case of deletion, I will just take out the value in a variable value, okay, from the top of the array. Then what I will do? I will decrement that top. Top is equal to top minus 1. This is the pop operation. Simple, right? So, let me show you how it will happen. So, this is the algorithm of insertion, push. The name of the algorithm is push insertion. So, I have taken the 3 parameter. Number 1 is top of the stack. Number 2 is the size. Number 3 is that element that we want to insert. Okay. So, we are going to insert this element x. Okay. So, firstly I will check. This is the insertion. So, for insertion I have told you we will check whether overflow condition is there or not. How it will be checked? It is checked if top is equal to size minus 1, number 1, equal to size minus 1, then no need to insert the element. Go to step number 4, exit. Okay. If top is equal to size minus 1 is not there, it means that we can insert the element. Then what we will do, we will just create the position. So how that position is created? By incrementing the top is equal to top minus 1. Then at that position in an array, we will insert that item. This is a simple algorithm. So respectively, I have shown you the C code of this algorithm. Void push, declaring the variable int x. Firstly, what I have to do, I have to check the overflow condition. Top is equal to size minus 1 equal to size minus 1. If this condition is true, then overflow is print and we will exit. Okay? Otherwise, else we have to perform the insertion, we have to perform the push operation. Then I will ask enter the element to be inserted to the stack. Okay? Scanf, with the help of scanf, I have asked the item which I am going to insert. Okay? Then what happened? I will increment the value top is equal to top plus 1. Then at that particular position, I will insert that item x. Okay, this is the respective C code of push. Okay, now the pop deletion operation, same, where we are going to delete the element from the stack with the help of a variable top, important variable, and what element I am going to delete, I have to print that this item is deleted. Okay, so we have to define this. So number one, we will check for underflow condition. What is the underflow condition? Top is equal to minus 1. Okay? If this condition is true, then it will print underflow and exit. Right stack is empty. Empty condition is underflow condition. Underflow condition, and we will exit. Go to step number 4, exit. Stop. Otherwise, what we will do? We will just take out the element from the top of the stack to my variable x and decrement the value of top. This is the algorithm. And how it is implemented using a C program, let us see here. We have make a function, the name of that function is pop. If top is equal to minus 1, it will print underflow. Otherwise, we will print delete item. How it will be printed? The item is taken out from the position of top and we will decrement top is equal to top minus 1. Okay. So this is the C function to delete an element. So likewise, I just pasted a screenshot of the program. Firstly, I have defined a macro hash define size 4. Okay, I have declared a variable array. This is the size. So in this case, 4 will be redirected here. 4. The name of the array is stack underscore array. We have initialized top is equal to minus 1. This is called initialization. Then I have use function, these three function, push for insertion, pop for deletion and show for displaying the elements. Okay. So I have used a menu driven program here. I have taken a variable choice. So while true, operations performed by stack. So I will press 1 to push the element, press 2 to pop the element, press 3 to show the element, press 4 to end the program. So enter the choice. So I will enter in case when I press 1, so push function will be executed. When I press 2, pop function will be executed, press 3, show function will be executed, press 4, no response, otherwise invalid choice. Okay. So the same function I have used here, push, pop and show function. So what is show function? Show function is that it will display the elements in the stack. So how the elements in the stack will be displayed? See, for example, these are the elements which I want to display, 11, 12, 13. Okay. So first element is 13. This is my first element. This is my second element and this is my third element, right? Last element is the first element because we know that the operation performed here is LIFO, last in first out fashion. Okay. So how we will print this? I have initialized a variable top is at I is equal to top. The last element it will be the first element which I have to pop. Okay. Until I is greater than or equal to 0, I minus minus. See, decrement operator will take place because while inserting the first element that we will print is 11. Number 1, top is equal to top minus 1. The second element is 12, then 13. So for that we have used the minus minus operation to perform it. So like this, these elements will be displayed. Okay, students. So should we move forward? So these are the time complexity that I have mentioned here for a stack operation. Only a single element can be accessed at a time in a stack. So the time it will take O1 time, big O of 1 for doing push and pop operation. Okay, so these are the application of a stack. Tower of Hanoi is an application, n queens problem is an application, and importantly infix to prefix conversion, infix to postfix conversion. Okay, also evaluation of operation will take place. These are the applications of a stack. Yes, number 1, number 2, number 3, number 4. Another recursion is also an application of a stack. Okay. Now let me introduce you what is a queue. As I have told that stack, there is only one end in case of stack, but in case of queue is also data structure where ends were exist. And what are the ends here? There are two ends. One is this end, another is this end. So both ends were involved, and that data structure is called as queue data structure. And the live example is when we stand in a on a railway station to take the ticket. So we just stand in a queue na. So the person which stands first will get the ticket and come out. Okay, and a new person that will come to take the ticket, it will just queue in the line. Okay, so this end is called as front end, and the end from where insertion take place, that is called as rear end in the queue. Okay, so a queue is also defined as a linear data structure. Just like a stack, the operations were performed in LIFO fashion. In queue, the operations were performed in FIFO fashion. First in, first out. First in, first out. Okay. We will define queue in a list. For insertion, we will take rear end. That operation is called NQ, adding the elements, and all the deletion from the list are made at the other end. That is called as, the deletion will take from the front end, FRONT, front end. Okay, front end, and that is called as DQ. Deletion is DQ, addition is NQ. Okay, insertion takes place from the rear end, deletion takes from the front end. Like see in the example here. So 3, 4, 5, 6, 7, 8 new element will be added from here. If we are going to delete some element, 2 is deleted, 2 is already there, it is deleted from the front end. Okay, that is called DQ. Deletion is DQ, addition is called as NQ. Okay, so FIFO principle of a queue is that we just like we are waiting in a line to purchase a ticket. So in what fashion the person who is standing first will get the ticket and come out. This is FIFO, first in, first out. Okay, and the next point that we have to keep in mind, there are two, just as in stack there is a top variable. In case of queue, there are two important variables. Number 1 is rear, number 2 is front. In stack, we have check whether stack is empty. How it is checked? Top is equal to -1. And in case of queue, if both the pointer is pointing to -1, then it will be understood that queue is empty. Okay, in the same fashion. In case of stack, we are checking only one variable. In case of queue, we will check for two variables, rear and front. Okay. So let us see with the help of an example. We are going to insert element in a queue. Okay. So I am going to insert element in a queue. First element is inserted A. So now what happened? Rear will pointing here and front will also point here. So rear and front both is having 0 position. Now I have inserted Q. So front is already there. Whenever we are going to insert, which pointer will be updated? Which variable? Rear variable will be updated. Now rear is equal to rear plus 1. Now we have inserted B, then rear will point here. So front will point to 0. I have written here front is equal to 0 and rear is equal to 1. And third operation again I am performing, inserting element in a queue, that is C, D, E, F. So C, D, E, F. So this is the position of the rear pointer and this is the position of the front pointer. Front pointer, that is variable. Front rear, the rear is insertion, front is deletion. Okay, na? Now the maximum size is, now rear is equal to 5, max size of queue, and front is equal to 0. Now we can't insert any element in a queue because queue is full. Then how it will be checked? With the help of this expression, rear is equal to max size minus 1. If rear is equal to max size minus 1, then it means overflow condition will be inserted. It will be inserted, it will be printed. So Q ID is overflow. If rear is equal to max minus 1, overflow will be printed. Okay. So what are the characteristics of a queue? Queue can handle multiple data. As we have seen, there are two pointer variables, front and rear. we can access both the ends, they are fast and flexible. ठीक है, तो how the queue is represented again? In the case of stack, there are two implementation. Same in the case of queue, there are two implementation, array and linked list representation, both. ठीक है, so these are the types of queue: simple queue, circular queue, priority queue, and double-ended queue. ठीक है, let me show you the simple operation, that NQ, how it is performed. Firstly, we will check overflow condition. Overflow condition, rear is equal to max minus 1. If rear is equal to minus 1, then set rear is equal to 0, else rear is equal to rear plus 1. ठीक है, then we will insert item in a queue, just like, for example, this is the first element that I am going to insert. Front and rear is pointing at minus 1. Now, if the first element is inserted, then what happened? This rear will point to R. Then we will check the element which we are going to insert is the first element. Then what happened? We will check F is pointing to minus 1, then it will start pointing to this front. So we have checked if rear is equal to minus 1, then set R is equal to 0, else rear is equal to rear plus 1, and Q rear is equal to that item will be inserted. This is the respective C function I have checked here. ठीक है, तो I am going to insert the first element. It may be the case now this is the first element. So I have checked here, if front is equal to minus 1, then I have to set front is equal to 0. Then item inserted, it will be printed here, and rear plus 1 is already updated. ठीक है, and what happened in DQ deletion? We will check for underflow condition. Front is equal to minus 1 or front is greater than rear, then underflow condition will be printed, and we will take out this the element which is pointing to the front. It will come to this variable item, and front is equal to rear. It may be the case the element which we are deleting may be the last element. It may be a case, for example, this is the only one element that I have to delete, front and rear. ठीक है, if we delete, front will be initialized to minus 1, and the condition is that this is the last element. So our rear pointer is also pointing to this now. So we have checked, if front is equal to rear, it means that Q has only one element. Then we will update else is equal to front plus 1. ठीक है, otherwise if this is not the last element, then front will be updated, front is equal to front plus 1. ठीक है, this is the C respective C function. We will check underflow condition, else element deleted, it will be printed and front plus 1 will be there. ठीक है students, so this is the display function where we have to display the number of elements. Just this is called traversing. In the same fashion, we will execute the for loop from front to rear, and we one by one we are going to print the element. Okay, these are the applications. Scheduling process in CPU, operating system, data transfer between processes, multiple jobs will be handled. DFS, depth first search, spooling. Spooling means in the case of jobs in printing, when printer print the jobs, that spooling is done. So this is the application of queue. So I hope that these two operations will well understood how we are going to implement in C. These are basic implementation, that is insertion and deletion. It will be well understood, and application of stack and queue that I have defined here. Okay, thank you very much.